Okay, I wanted to do my next video on the second set of readings under the Unit 1 reading. I am going to do my second, and I just added one here for the introductory reading. And I'm just trying to give you a quick overview of some of the key concepts that I want you to pick up as you read about some of these topics. These readings here will be specifically over the Sun Angle Lab, and you will have a quiz over energy in the atmosphere and the seasons. So there will be two assignments, and it tells you right there, the Sun Angle Lab and the Energy and Radiation quiz. And so I'm going to show you one of the very first things I want you to pick up is you should recognize that there is a Earth's tilt of 23.5 degrees, which we call the axis, is going to determine so many things about the Earth's seasons, when they occur, the temperatures around the planet. And this is where you're going to connect together your understanding of latitude in particular, understand why places between the equator, the Tropic of Cancer, and the North and South Pole, why the climate and the seasons are so different for countries around the world. There are two motions that you're going to basically be learning about. Is this will be the concept of the seasons, of how the Earth moves around the sun in 365.25 days. And we call this a revolution. And this is what you're going to be talking so much about when we see the Earth's tilt and how the sun hits different areas of the Earth. I can tell you, you'll need to know that, like, this will be the Northern Hemisphere summer, this will be the Northern Hemisphere winter, and this will be the equinoxes on the side. You'll be doing a lab on that, and that's a revolution. A rotation is the Earth sitting and spinning on its axis, and it takes 23 hours and 56 minutes and 4 seconds for one complete rotation, and that's the concept of a time. And that's so much tracked by longitude, and that's why we have time zones. And so when we talk about rotations, we tend to talk about east-west more in longitude. And when we talk about revolutions, we talk about the seasons and latitude a lot more. So you'll see that with our very first lab on the Sun Angle Lab for this topic. This is one of my favorite topics, is the role of energy and how energy moves through the vacuum of space from the sun and what are known as the electromagnetic spectrum. These wavelengths are in micrometers or nanometers, and they basically go from the strongest rays from the left to the weakest rays on the right. And understanding electromagnetic radiation from the sun and how it interacts with our atmosphere and our Earth is what determines how the Earth's climate is sort of shaped and structured. And you're going to see that much of the electromagnetic spectrum is in a very narrow band that we call visible light. And that's from violet to the reds and the oranges. And you'll have to understand that every object in Earth and its atmosphere has a variety of interactions. Some absorb the certain types of radiation, some reflect, which we call albedo. Objects that reflect radiation tend to stay relatively cool, but objects that tend to absorb tend to heat up. So the temperatures around the Earth are all based upon to what extent are surfaces absorbing or reflecting radiation. So like blacktop is a very good absorber, and that's what causes when blacktop absorbs much of the sun's radiation. We find out that, by the way, the Earth and the sun, the sun's radiation tends to be more over on this side, which is the short waves. Over on the right side, we tend to get more of the long waves. And so Earth's temperature is based upon to what extent are the sun's short-wave radiation going in balanced out by the long-wave radiation going out. Energy that is absorbed causes the molecules that are absorbing it to vibrate, and that's what causes the temperatures to go up. And then make sure you understand and can compare and contrast the difference between temperature and heat. And heat is the energy that moves moves when there are differences between temperatures that are near one another of hot and cold temperatures. And so the energy that can be stored in an object that can be moved is called heat. And certain surfaces and certain objects absorb energy and store heat differently than others. Some simply need more heat to raise the temperature of objects more than others. So like water has a very high specific heat, and they talk about it here, and that's why oceans take more energy to heat up or cool down, whereas land surfaces tend to have a lot less. And that's why in the Midwest, we tend to be like a thin hamburger, and we can heat it up very quickly and cool off, versus oceans tend to be like chicken, and they require much more energy to heat up and cool down. And so we'll get into this more in Unit 2, but it's introduced in this unit as well, and you need to understand, and so many industries around the United States and world are all users of electromagnetic radiation. So if you're in the cell phone industry, you're doing a lot of long wave movements with television and radio waves. You're in weather forecasting and military applications. We use radar. If you're cooking food and whatnot, you're using infrared. Get a sunburn, that would be ultraviolet. If you're going to the medical industry, you often use X-rays. These waves on the left, again, tend to be your stronger, shorter waves, and the waves on the wavelengths on the right tend to be your weaker ones. And so I just wanted to kind of give you an overview on that and kind of prep you for the unit. The energy from the sun is primarily in the shorter wavelengths, like visible light and ultraviolet light. And this overview is kind of highlighting how the sun's rays strike the earth, and at different times of the year, they hit at different angles, indicating and directing different magnitudes of strength. So when we do the Sun Angle Lab, we're going to look at areas around the equator with a latitude of 0 versus areas near the poles that have a latitude of near 90 or negative 90 in the South Pole. How at different times of the years, the sun's rays, based on the angle and the length of the atmosphere they have to pass through, are going to cause some places like Africa near the equator to be much warmer than areas like Canada and Russia near the poles to be much colder, all based upon the angle of the sun. And this is all tracked by looking at different times of the year with the angle of the sun hitting different areas of the earth at different angles. So you will see how our atmosphere interacts and shapes how different how different magnitudes of radiation are hitting the earth in different places. And again, this is why you need to understand latitude, because by latitude, we kind of get an idea why areas are going to get differing degrees of radiation receipt. The last video here is that because the Earth is heated differently and some areas get more energy than others, heat moves constantly from areas of where there's more concentrations of energy to areas of where there's less. And so they basically talk about in this diagram here, and we'll get more into this, is we're going to see how short-wave radiation comes in from the sun and how long-wave radiation moves out. And this is what creates the greenhouse effect, and certain gases are basically trapping the energy that the Earth absorbs in shortwave. The Earth re-radiates long-wave, and to differing degrees, the amount of shortwave in is balanced by the long wave going out. That's what determines the planet's overall temperature. And certain gases like carbon dioxide, methane, nitrous oxides, and ozone, these are all regulatory gases that can kind of control how much of the sun's radiation comes in versus how much of the energy gets out. And this is why the Earth sits at an average temperature of around 59 degrees. However, if you get more shortwave energy in than you have energy going out, you would have a planet warming. And if you have more energy going out from the Earth leaving the atmosphere than energy coming in, you would have a planet that's cooling. And so they kind of introduce to you that heat is constantly moving around the Earth because the Earth is not heated equally. Some places there's more than others. And this is what we're going to be getting in, why there's such a geography of weather and temperatures, because the energy moving in and out is unequal, and certain areas get more energy coming in than others, like around the equator, and that's what we'll be talking about throughout this unit. So we'll have a lab directly on this concept in this section of Unit 1 or Module 1 on radiation and energy movements in the atmosphere. So I believe that is everything on this section, and you will have two assignments on these readings, and I'm going to post this video on here later today. So I will leave it there, and I will stop the video.